Okay, today we're going to do another example of population growth, and this time we're going to talk about fruit flies. Okay, so again, I'm going to read the problem, so take notes, pause, whatever you have to do. So it says here, suppose a population of fruit flies increases at a rate of g of x, or excuse me, g of t. Okay, so let's say the growth rate is g of t equals 2 times e to the 0.02 t. So that's the growth rate of fruit flies. And this is in flies per day. Okay, flies per day. So we get the units. If the initial population of fruit flies is 100 flies, well, that means at t equals 0, right? So at t equals 0, g of 0 equals, what was it again? 100 flies. It's a lot of flies. Okay. How many flies are in the population after 10 days? So we want to know what, and again, this is in, t is number of days. Yeah, per day, right? So we're doing per day. So t is in days. So what is g of 10? That's what we want to find out. Okay? Okay, so let's set this up. Oops, sorry. Okay, so here's our function. Oops. Oh, let's see, is that right? Let me see, is that what they were? Oh, I'm sorry. Yeah. Yeah, we want, this is Q. Yeah. Q of 0. I think on the last example problem, I think I wrote the wrong symbol. I think I wrote, or not Q, G. I'm getting mixed up with the last problem. So G. Okay. In the last problem, I think I used lowercase g when I should have used capital G for this one. So make that correction in your notes. Okay, so now that's all the information we have, right? I think that's all we need. So let's set this up. Now, the last problem we set it up as an indefinite integral. This time we can set this up as a definite integral. Okay, so the last time we had a constant, we had to solve for the constant. So let's do it differently, and I'll show you what I mean. We're going to use a definite integral. Okay, so we know the initial growth, right? So we can set it up this way. We can say that g of 10, that's right, g of 10, yep, is equal to g of 0 plus what? g of 10, or plus the integral from 0 to 10 of g of x, or g of t. Do you see anything wrong with doing it that way? So all we're doing is we're setting up with the initial population size plus all the other that was added from t equals 0 to t equals 10 days. Okay, so that means this is going to equal 100 plus the integral from 0 to 10 of what? Of this. 2e to the 0.02t dt. And so now, let's integrate. So now in this case, I'm going to do a u substitution. So what's the u substitution we're going to use? Well, I'm going to make u equal to 0.02t, and then du is going to equal 0.02 dt. And then, of course, I'm going to divide, oh, actually, you know what? Yeah, I'll just divide. So I'm going to make this into du over 0.02 equals dt. And so now I'm going to substitute in, and again, I've got to change my limits of integration as well. So when t is 0, what? When t is 0, u is 0. That doesn't change. When t is 10, u is 0.2. Okay, so that's going to be my limits of integration. And so now I'm going to pull the 2 out, and it's going to be e to the, well, I'm going to divide by 0.02, so I'm going to pull that out, 2. Okay, and so I've got 2 divided by 0.02, and then e to the 0.02t dt. Oh, excuse me, hold on. U. du. Because I did my substitution. So all I did was going from here to here was do my u substitution. So I substituted in du divided by 0.02. There's my 0.02 in my du for dt. And then the 2 and the e to the u. Okay, so now I'm going to integrate. So let me go over here. And so I'm going to get 100 plus, now 2 divided by 0.02 is going to be 100. Right? So 2 divided by 0.02, yeah, is 100. So it's going to be 100 times e to the u evaluated from 0 to 0.2, which equals 100 plus 100 times, and this is going to be e to the second power minus e to the 0 power, right? Okay, so let me stop there. Does that make sense? Okay, so now, what happens? Well, this becomes 1, so I'm going to get 100 plus 100 times e squared minus 1. And at this point, you could stick this in your calculator. Okay, I wouldn't do any more than that. Okay, so if you put it in your calculator, then you would get approximately 122 fruit flies. Okay, that's it. Here's another one for you. So try this one on your own. So let's say we have a growth rate of the fly population given by g of t equals e to the 0.01 t, and we have an initial fly population of 100 flies. How many flies would there after 15 days? What would be, how many flies are in the population after 15 days? So when t equals 15, oops, not q. Okay, that's for you guys. Okay, have a great day.